Hei og velkommen til Din helse, podkasten hvor vi ønsker å veilede deg i jungelen av tips og råd om helse, vektnedgang, trening, ernæring og så mye mer. Virkelig god helse krever at du stiller deg kritisk til alle disse rådene, og det skal hjelpe deg med denne podkasten, slik at du kan finne din helse og leve ditt beste liv. Jeg heter Tore, og i dag har jeg med meg Dan Quintana. Kristine er, som dere kanskje vet, på ferie i Sør-Amerika og klarte derfor ikke å stille opp denne episoden. Men frykt ikke, dette blir en spennende episode. Et av mine, noe som jeg er veldig opptatt av, med pulsvariasjon og HRV. Så fordi Dan er ikke så komfortabel i norsk, så kommer jeg til å gjøre dette på engelsk. Så får håpe at dere henger med på det. Jeg skal i hvert fall forsøke å holde det ryddig og enkelt å forstå. So Dan, welcome so much to the podcast.
Great to be here. Thanks for the invitation.
Yeah, so for those of you that don't know Dan, Dan is a professor of psychology at the University of Oslo. His main research interest is in the investigation of biological systems that link psychosocial factors to health, with a focus on hormone systems and the cardiac autonomic nervous system. His other research interest is in meta-science, which is the evaluation and improvement of research methods in psychology. He also co-hosts Everything Hertz, which is a podcast on research methodology and scientific life. So great to have you here, Dan.
Yeah, great to chat about this. Very interesting topic.
Yeah, so kind of like an introductory question. I'm curious to what made you interested in this topic and HRV in particular.
Yeah, so I originally was very interested in elements of social psychology where we ask participants questions, we give them questionnaires in order to get a better understanding on what makes people tick. But I began to get a bit frustrated about the subjectivity of these things, about asking people questions like this. And I became very interested in objective measures like heart rate and heart rate variability as a better way to understand how we think and feel. I did my PhD looking at heart rate variability, particularly in the context of the effects of alcohol consumption, both moderate alcohol consumption, but also alcohol dependence, and how these things affect our heart rate variability. And I fondly remember doing all my research on a very humble Polar watch. It was an old Polar watch where I collected almost all my data. So it was very, right now I speak to a lot of people that have all these very complex and very expensive pieces of equipment to collect data. But I was very happy thinking back to my PhD where it was collected on a relatively cheap sports watch. So that's what got me into it, the objectivity as a way of measuring and better understanding how we think and feel.
Yeah, that's awesome. I also, as I told you before we started, I also did my master's on overtraining, and I found HRV to be a very valuable tool to use for measuring an athlete's fatigue. But maybe we can start with if you can say what does HRV or heart rate variability actually measure, and what does it say about our health and ability to cope with stress?
Yeah, so I think it's really important to define this because a lot of people, this term is becoming a lot more popular, but I think it's important to remember the origins of this term. And essentially it is a way, well, the strict definition is it's looking at a way to measure the variation from heartbeat to heartbeat. Quite often we think that our heart works like a metronome in that it beats constantly, but there are very subtle differences in the period between between heartbeats, and we can measure this using various tools. Traditionally, we've used electrocardiogram or ECG to measure this, but there are now emerging more ways that we can do this in terms of our watches or rings. These are various ways that we can measure the activity here. But it's important to highlight that all these measures of heart rate variability are used as an indirect index of autonomic nervous system function, or the activity of the cardiac autonomic nervous system. Heart rate variability, there's a ton of different measures there. Last time I checked, I think over 80 different measures have been proposed, although a number of those are more popular and more used than others. All these measures do measure some sort of way of looking at the variation from heartbeat to heartbeat. But a lot of the measures that were used originally were used because they can be a good index of these things. Some of these measures look at the autonomic nervous system as a whole. Other measures specifically focus on the parasympathetic nervous system activity. And those are the measures that I focused on in my research. And these have been validated various ways. But I think one of the most convincing ways is that there are ways that pharmacologically you can completely knock out the parasympathetic nervous system activity. And there you can specifically look at the changes of these measures before you knock out these systems and after you knock out these systems. And it's very clear that some specific measures of heart rate variability index the parasympathetic nervous system activity. Now, there are some claims that you can measure the sympathetic nervous system activity using heart rate variability, but that's simply incorrect. There's no way, at least to my knowledge, that you can accurately measure the sympathetic nervous system activity using HRV alone. There are some measures that get at aspects of the sympathetic nervous system, but these are both the parasympathetic and the sympathetic nervous system. Another misconception that I commonly find, both in the popular press, but even within the scientific literature, is that the parasympathetic and sympathetic nervous systems work as kind of like a seesaw. As one goes up, the other goes down. This does work sometimes in some situations, but physiologically it's possible for both to go up or for both to go down. And consequently, what you find is that a lot of people will say, well, if my parasympathetic nervous system activity has dropped, then that must mean that the sympathetic has increased. It may be the case, but it may not necessarily be the case. So when it comes down to these things, when we're measuring heart rate variability or when we're using specific measures of heart rate variability, we can accurately measure parasympathetic nervous system activity. And this can offer a window into our health. I've looked at a whole range of different psychiatric disorders and conditions, and in almost all these conditions, there is a reduction of heart rate variability, which means there's a reduction of parasympathetic nervous system activity. The only condition that I know of where HRV is actually increased is anorexia nervosa. This doesn't mean that these folks are healthier. Quite the opposite. What it actually does mean is that there's other factors in play which is causing this increased heart rate variability. Essentially, folks with anorexia nervosa have a very, very slow heart rate, which in a way is a energy preservation strategy, and that's leading to increased heart rate variability. So it's not one of those things where an increased heart rate variability is necessarily always good. It always has to be seen in context there. So it can be seen as an overall measure of well-being because it is an index of an overall measure of stress. We have seen these differences or reductions in HRV across a bunch of psychiatric conditions and disorders, but the one factor that seems to be common across all these conditions where you actually see increased or reduced heart rate variability is anxiety or stress. Folks that have higher levels of anxiety or stress tend to report, so if you have a higher stress, then you have lower heart rate variability and vice versa. That seems to be the common aspect across all these psychiatric conditions. So it can be seen as a general measure of well-being, but more specifically, a general measure of just anxiety and stress.
That's very interesting. I was not aware that does that also mean that Garmin and all these Aura and these devices, they measure the parasympathetic activity for the HRV, or?
That's a good question. The specific measures used, all these different wearables used slightly different approaches. Some of the measures that they use specifically will index parasympathetic nervous system activity. Others will be a more broader measure of the autonomic nervous system. But again, you can't say with these measures whether it's targeting the parasympathetic or sympathetic alone. You need a measure that can specifically target the parasympathetic nervous system activity. And this depends. Different manufacturers use different approaches. I think many do use these approaches, but in many circumstances, it's very difficult to know, A, what they're measuring, and B, what they're doing with the data. And quite often, you're not getting a measure of heart rate variability. You're getting some sort of index. It might be readiness, or it might be your body battery. And this takes into account all different factors, which include HRV, but you're not necessarily getting a direct HRV measure. HRV is used in combination with other factors to give you this final number.
Yeah, the body battery measure you could say that it's not exactly a direct measure of your heart rate variability. It's more kind of they're using different algorithms, perhaps based on HRV? Do you know that?
Yeah, so HRV contributes to this, but it uses other factors. So it's quite unclear. I mean, that is their competitive advantage to have these new metrics. So it's not in their interest to actually share how they're doing it or how they're validating it. We do know if you are using a device which can measure something. So for instance, there are three popular measures which can directly measure parasympathetic nervous system activity. RMSSD, which many apps and devices do use, PNN50, which is very closely related to that, and also the high frequency variability as well. High frequency variability is very susceptible to artifacts. If you're moving, if you coughed, for instance, whereas RMSSD is less sensitive to those things. You can use these in order to get a measure of HRV. Some of these devices will tell you, here is your RMSSD. That is, all things being equal, relatively reliable. You can do that. But then other devices are using all sorts of other things to give you a measure that we don't actually know is accurate or not.
Could you say a little bit about what measures are the most reliable, except, of course, the ECG, which I assume it would be the most reliable for measuring HRV?
Well, I mean, ECG is considered the gold standard. It is, at least in the laboratory, it is what we typically use. One of the benefits of ECG is it's relatively easy to understand the source of artifacts. When we're measuring HRV, what we're really doing is we are looking at the influence of the autonomic nervous system and how that influences the sinoatrial node, which is the heart's pacemaker. When we're measuring variability, we're essentially measuring the activity of the heart's pacemaker. Every pulse that we get isn't exactly the activity of the pacemaker. It's a little bit delayed, but it actually represents what's happening at the pacemaker. So what we're doing there is we're getting this indirect measure of what's happening.
So when you say pacemaker, are you then referring to kind of the parasympathetic activity of slowing down the heartbeat?
Yeah, so both the sympathetic and parasympathetic nervous systems have activity on the pacemaker. So when we're actually measuring things such as RMSSD or the high frequency variability, we're measuring this the parasympathetic input on the sinoatrial node. That's what we're specifically measuring here.
I see. What would you say? I mean, with all these devices on the market, you can now get your HRV with a smartwatch, with the Aura Ring. I personally use a heart rate strap, which I connect to an app. Can you say anything about the different methods and what methods are like more reliable for that?
Yeah, so ECG is considered the gold standard. These other methods can get you pretty close. They're pretty good. We have done these sort of validation studies where we compare ECG against, say, the chest strap, or against a finger sensor, which is what's used in the ring, or you can even use a smartphone camera as well to measure these things. They're not that bad. The benefits of using ECG is that you can detect what the source of artifacts are, whether it's movement, whether it's a general arrhythmia, to make sure that what you are measuring is this parasympathetic input on the sinoatrial node. So the hardware itself, assuming you are a relatively healthy, youngish person without any cardiovascular issues, the hardware is pretty good. It's not clinically reliable, but in terms of research, it is research reliable, assuming you're a relatively healthy person. So this applies for pulse oximeters, for chest straps, for watches, for rings. You can get a pretty good measure looking at these interbeat intervals there. They're not as good as ECG, but they're pretty close. So yeah, in terms of research, like I mentioned before, I've used these things in the past. And if you're working with a healthy population, yeah, they're pretty good.
So you would say there's value in that, using these different, if it's an Oura ring or if it's a heart strap or a smartwatch, you would say there's value in measuring HRV, even though it's not 100% accurate?
Well, I think it's important to say that the hardware works well and the hardware can give you an accurate measure. What is important is how it's actually used. So there's a lot of factors that can influence HRV. So if you're collecting it in the middle of the day and you've just had a big meal or you've drunk a lot of water, things like that, or you've just been moving a lot or you're currently moving, things like that can influence measurement. So as well as there's three factors. It's the hardware, it's the software, and it's the context. Hardware is good using these devices. Software, it depends on what they're doing with the data. So there are some apps and devices where you can get the raw HRV data. It's giving you an established HRV metric. The alternative is some metric that they've come up with for clever marketing. That thing works as well. And it's also the context as well. There's a big difference between measuring it first thing when you get up in the morning versus in the middle of the day where there's so many different factors which can influence HRV. So under the right conditions, using most sorts of hardware under the right conditions and assuming it's outputting actual HRV, an actual HRV measure, and not some other sort of index, then yes, these things can give you accurate readings, which are very close to ECG.
Yeah. So, but as I understand that the smartwatches, for example, they measure HRV throughout the night versus if you have like a chest strap, which I personally use, you do measure in the morning. Could you say a little bit about these two methods and what method is like more reliable?
Yeah, so the night measures are interesting because generally you're not moving. Of course, you move a little bit during your sleep, so you can get a indication of what's happening across the night, but there are slight differences depending on your sleep stage. So when you're actually getting this final metric, you have to understand, is this metric looking at sleep across the whole sleep period, or is it looking at specific sleep periods? If you're getting differences, it's unclear whether it's due to the sleep period that you're in or whether it's due to other factors there as well. So as a broad overall measure, yeah, it's not so bad. There aren't any influences of meals or stress, or at least real-time stress. Whereas if you're looking at first thing in the morning measurements, then that's a little bit more standardized because you're sort of awake. It's typically the same time of day. Some people recommend that you should do it like you're still lying in bed and that you should do it, or you should go to the bathroom first. That's another example of a factor that can influence HRV. How full is your bladder? If you're doing measurements in the morning and sometimes you're doing it before you go to the toilet and after you go to the toilet, you're going to get some differences there. So it's really important to standardize this. It's also important to standardize, were you sitting up? Were you lying down? Even that's going to give you some differences there. So those are some important factors. So if I was measuring what is happening with my HRV from day to day, and that's another really important distinction. What's most important is what's happening when changes on an individual basis. A lot of the findings that we have is based on group level findings, but and we also don't have very strongly established baseline measures of what's high HRV and what's low HRV. Very regularly in my inbox, I get an email from somebody going, I'm a part-time triathlete and I want to show you my HRV data. Is this good? Is this high? Is this low? I can't tell them because this is an individual thing. And there have been some studies which have, let's collect HRV in 1,000 people and look at the numbers. The average RMSSD is 40 or 50. There still are differences there. It's not reliable like blood pressure. So with blood pressure, we have established measures. This is low blood pressure or high blood pressure. We simply don't have that with HRV. We don't have these established norms there. So what's more important than thinking about what is my number is how these numbers changing over time. If you're collecting it every morning, first thing when you wake up, such as yourself with a chest strap, and using the same conditions and looking at how these things change from day to day, that can be one way or one sort of tool that you can use to look at your overall well-being.
Yeah, so it's more kind of the long-term trends that are of value, not what the single measure shows, but more kind of like the long haul. Where is the HRV baseline going?
Yeah, so I mean, you would look at a single measure, but then compare that to the last couple of weeks. Yeah, are things improving? Are they going down a bit? How is this compared to how the sort of HRV that you normally have? That is an approach that I would recommend.
Yeah. I want to take a step back maybe and talk a little bit about what other factors impact HRV, because you said even though like just the hydration status or if you have a lot of stress, these kind of things. But can you talk a little bit about that? What factors, also like genetics and gender and that kind of thing?
Yeah, sure. So in terms of genetics, like almost any sort of physiological phenomenon, there is various levels of heritability. All things equal, identical twins will have similar HRV compared to non-identical twins. There are some genes which have been associated with HRV. So essentially, they've run these big gene-wide association studies where they map the genome of thousands of individuals. I think the largest one was with 50,000 people, I think. And they also measure HRV. And they look at, in an exploratory way, are there any genes which contribute to this? I think it's really important to stress that there is no HRV gene. Very few disorders are what they call monogenic, where you have a single gene which contributes to these disorders. Some do, where there is a single gene, but most human characteristics, and HRV is an example, is a result of variation across many, many genes, sometimes hundreds of genes. In the case of HRV, at least 10 genes have been identified which are associated with differences in HRV. And most of these genes are highly expressed in the pacemaker, in the sinoatrial node, in the heart's pacemaker. But these differences are small. They're modest. There are certain physiological, or there are certain disorders, for instance, which are highly heritable. Schizophrenia comes to mind, whereas there are other traits which are less heritable. So HRV has a degree of heritability. There is a degree of genetic influence, but it's not destiny. You shouldn't go and take a test, or people might talk about getting a polygenic score for HRV. It's very, very modest. All that to say, there is a modest genetic component towards that. Age makes a difference as well. So HRV tends to peak around adolescence. Again, these are averages. There might be differences for individuals, but looking at broad averages, it peaks around adolescence and then slowly drops over time. So the older you are, the lower your HRV. Women tend to have, on average, slightly higher HRV. This might help explain why women are less susceptible to cardiovascular issues. One of many, many reasons. So that is certainly a factor. So those things contribute there. In terms of short-term stuff, big meals, drinking a lot of water can influence this. We actually did an experiment on this back near the end of my PhD. We were curious, like, what is the relationship between these things? So we simply did a test where people came in. They came in 4 different weeks. One week they came in not hydrated. Another week they had a little bit of water, a lot of water, and a lot of water. And there was a very strong dose-dependent relationship on the effects of water intake on HRV. These things can make a difference, which is, again, why it's so important that if you're interested in this, measure it first thing in the morning when you haven't had a meal, or you haven't had a drink of water, or what have you. So those are some of the more important aspects. Also, certain lifestyle aspects as well. So all things equal, somebody who has stronger cardiovascular fitness will have higher HRV. A lot of that is a function of having a lower resting heart rate. The lower the resting heart rate, then the more opportunity there is to have variation there as well. And certain lifestyle factors. So if you're a habitual smoker, or dependent on alcohol, for instance, those factors will also increase HRV as well. So there's various lifestyle factors there which can influence these things.
Yeah, it's also my experience that so many things influence HRV, so it's hard to know exactly what leads to lower HRV from day to day, because there can be so many things, right?
Exactly. I'm very skeptical if people can claim, well, it's this was the thing that reduced HRV. Maybe there was something which reduced your stress, and in the process of reducing your stress may have indirectly influenced HRV. So it is very sort of broad. It's very hard to think of it as being a very specific thing. One sort of analogy is it's like a measure of inflammation in the blood. Like CRP is a is a common measure of inflammation. You can take this and you might say, well, you have high CRP, you have high inflammation, but it's very difficult to actually understand what is the source of this particular thing. HIV is the same sort of thing. Well, there is some stress in the system somewhere. What the source is can be different. Maybe it's very obvious. Maybe you've, going through a very stressful event. Other times it might be less clear.
Yeah. Um, and I kind of want to go a little bit more into this HRV measurements, and the question I get a lot is like, with all this technology now, it's like, how do you actually interpret the data? Because a typical smartwatch, you'll get a lot of numbers, and how would you say would be the best way to try and understand it and make use of these measures?
Yeah, so it comes back to the measure that's being used. Look at the apps that you have, and look at the documentation to see exactly what's being measured. I think Apple Watches use SDNN, I believe, and that is a measure that looks at general or the autonomic nervous system in general, which is both the sympathetic and parasympathetic. Can be useful, but it's not a direct measure of parasympathetic. One app that I do know of, which I've played around with myself, is HRV for training. This is a nice app. You can connect it with your chest strap. You can use it via the smartphone.
Yeah, that's the one I use actually.
Oh yeah, I
Yeah.
recommend that one because you are getting a direct measure of HRV. It uses RMSSD as a measure of parasympathetic nervous system activity, and then you know what you're getting. With other apps, if it's unclear what you're getting, it's difficult to know how the calculation is made. Whereas an app that directly takes a measure of HRV, like HRV for training, then it's gonna be much more informative for you.
So it's basically the algorithm that it takes a direct measure. So it's more, how do you say it? Even if you use a Oura ring or a chest strap, the algorithm in this app makes it more reliable, would you say?
Well, it uses an established algorithm to calculate RMSSD. And because it's an established algorithm, we know what it's doing. We know the validity of this sort of thing. Whereas other apps might use different algorithms that have not been publicly validated. So we're not quite sure what's happening there. But within this, you get this specific value as well. Other devices allow you to simply collect the raw data, the raw interbeat interval data. So, some Polar watches, for instance, allow you to do that. Then you can download that raw data and calculate it yourself. There are various apps that you can do this. These algorithms have been around since the 70s of how to actually calculate heart rate variability. One app which I use also in a research context is called Cubios. And with that, you can export raw interbeat interval data from various different smartwatches and devices and calculate it yourself. So at least you have full trust of what's happening with the data. But the key thing to look for in your devices is what metric is it actually calculating. If it's saying it's calculating RMSSD, then you have a fairly reliable measure of parasympathetic nervous system activity.
So it's the number, RMSD number, that's actually of value here.
Yes. So again, there has been validation population studies to actually show, well, this is like, if you're a 30-year-old male, this is the average here. That particular number, that's the number that you're looking at, which may change from day to day. So you may look at an overall trend, it's been around 30, and then you wake up one morning and it's dropped to 15. That's when you think, okay, something's a bit different here, or it's increased, for instance. That is the specific number that you're looking for.
Yeah. And kind of like the $1 million question is a higher HRV always good? And as a follow-up to that, is a low HRV always bad?
It's generally better. As I mentioned before, there are some conditions where you do have high HRV, but the things that are causing that are very bad for your health. So in anorexia nervosa, for instance, that's because you have high HRV because you have, generally speaking, a lower resting heart rate. And that's not because of, general fitness factors. It's because of low energy intake, which is putting the body into hibernation mode. So, or if you have a very erratic heartbeat, that is also going to give you higher variability, but not for the reasons that you want. Again, because there's no established norms, it's very difficult to say at what point is it, at what point is high too high. That's why you have to look at your own data to see how these things change. Same thing with variability. That's too low. There could be various reasons for that. You don't want it to be too low. Again, one of the sometimes get concerned emails that I think my HRV is too low. It's very difficult to know what that exact threshold is, but it is important to know that, particularly when it comes to high HRV, high isn't always necessarily good. Think about it in the context of your own data and your own information. Fortunately, we're not at the stage where we can actually give established norms of this is the sweet spot, or this is too high, or this is too low. Think about it in terms of your own individual change.
Yeah, that's good advice. And I actually see it with some of the clients I work with that if they are overtrained or burned out, they had high stress over a bunch of time and not recovering enough, then actually sometimes the HRV will it will be low for a good while, and then it will kind of go up really quickly. And then is that a common thing you see as well with when you look at more mental stress and that kind of thing?
Yes, I mean there is, if the stress is reduced, which is easier said than done, then these changes can have an influence, and they can they can increase HRV, or if the stress increases, then this can decrease HRV as well. So this is something that we see within the context of psychiatric conditions. Yeah, certainly. And I guess that would also that also translates to physical stress as well. So sometimes the body doesn't know the difference between this physical stress and mental stress. They affect your body feels like it's in danger regardless, and that can be reflected by HRV.
Yeah. I'm also a little bit curious about if we can use HRV as kind of a measure to determine how much stress we can handle or how hard we should train. Because I do sometimes feel that my own HRV measurement, it can be, for example, lower one day and I actually feel more energized. I feel more ready to go have a good workout. Whereas other days, if my HRV is really high, sometimes I feel a bit more like sluggish or I don't feel my best. Do you have any thoughts on that?
Well, again, I think it could be used as one of many tools. You have to listen to yourself. I have a few clinical psychologist colleagues who have a number of people that come into their practices going, my HRV is very low, but I actually feel quite good. What do I make of this? And then they'll respond, well, go by with how you're feeling. Go by with that. It can be in terms of training and overtraining. There is certainly some evidence to suggest that if you adjust your training in response to this, it may be beneficial. But it's more important to look at look at the bigger picture and to have this as one way of potentially informing how things are going within that. If you're feeling good, barring any sort of particular injuries, then go for it. Don't let this one particular thing dictate how you go. Use it as an overall, as one of many ways to help make your decisions of how you're approaching your training.
Yeah, that's very good advice. So also the thing I said to my clients that you shouldn't get too dependent on this what this watch or this app is telling you. That you should always kind of listen to your body as well. And if you feel good, then you shouldn't let the watch say you had a bad night's sleep and you cannot train. You shouldn't let that dictate your day. Kind of if you feel good.
I totally agree. And there is a lot more talk of people like letting these measures dictate their days, both in terms of training, but also just facing the day-to-day lives. The watch told me I had a bad night's sleep. The watch told me I have a low body battery, and that in itself almost sets you up. Can potentially set you up to have a bad day because you have this expectation of, well, I'm going to have a bad day, but you should go with how you feel and just use this as an additional metric that you can use.
Yeah, I think also part of the problem is that some of these smartwatches, they're giving you so many numbers, and the body battery is one example. They also give you this readiness score. They give you like a recovery or a conditioning number. There's so many numbers that it's easy to get overwhelmed and think, what does this mean?
Yeah, and we don't know the validity of a lot of these numbers as well. So yeah, sticking with what we know that works, which is these direct measures of HRV, can be useful, but it can be very easy to fall into the trap of following these numbers when we're not quite clear what they mean.
Yeah, yeah, absolutely. That's also why I recommend people I work with to kind of stick with one measurement and
Yeah,
then use that in combination with how you feel and kind of your own subjective assessment of your energy and health.
yeah, I totally agree.
Yeah, so we could say in general that higher HRV is good. So, kind of as a follow up to that, what can we do to increase our HRV over time?
I mean, one thing, again, easier said than done, is reducing stress in our lives. For many people, that's just simply not possible. Quite often, you hear stuff like people doing talks on, oh, you just have to get more sleep. And then you can see the parents of young children in the audience are shaking their head going, it's just not possible for me. So that's one thing. Like I mentioned, there's general lifestyle factors which can increase HRV. But again, these factors themselves aren't directly influencing HRV. They're influencing other factors which influence HRV. So, heavy alcohol consumption, for instance. Getting sufficient sleep for your needs. There's no magic number either for how much sleep you should have. This is individualized. Some people can get by with more or less sleep. It's figuring out what you need. Those things can certainly help. General cardiovascular fitness can also increase HRV. A lot of that is a consequence of actually just having a lower resting heart rate. That in itself can contribute to having increased HRV as well. So there are various things that we can do over the long term as well. But again, we have differences in day to day. You might be measuring your HRV and you just notice there's a drop. Those things happen. There's a lot of things that are very context dependent, but there are certain things that you can do over the long term to increase HRV, which is lifestyle factors, general cardiovascular fitness. These things can contribute.
What I see in my clients in particular, a lot of them are struggling with burnout, fatigue, and that kind of thing. And see that if you add too many things like high intensity exercise, cold immersion, or
Oh, yeah.
like there can be a limit to how much stress your body can uh, handle, and then we actually see often that HRV goes down. But then I say, okay, then you need to actually take a step back and recover from maybe doing a little bit more low intensity workouts as well, because people over here they get so into the high intensity stuff that they forget that the body also needs recovery, right?
Yeah, you need to have that recovery there. It's very important. I think another thing as well is that over the short term, stress is beneficial. It tells you something's happening in the environment and we need to change our behavior. So we shouldn't be avoiding stress at all costs. I mean, it's a general principle of weight training where we're applying we're stressing muscle tissue in order to grow. All that to say, it's the long-term stress which is a problem. Burnout can be a huge issue, particularly within a work context, where you have that it's just hanging over you. So you need to be careful around. You need to be careful there, and if you don't recover, then this can sometimes be reflected in HRV.
Yeah. Also, a lot of times, like you say, it's not maybe the training that's the issue. It's more like the lifestyle factors or kind of more mental,
Yeah,
psychological stress.
yeah, absolutely. Those things can also have a big contribution.
So, what have you learned so far about kind of mental health and HRV in your research?
So it's as we began looking at different disorders, we found that it would seem to be reduced across all the disorders that we looked at, except for anorexia, which is that one exception there. So, I mean, we were hoping that this could be used as a biomarker, as a way. This is the holy grail, one of the holy grails within psychiatry and psychology. Can we do a simple test, much like we have with various somatic or physical illnesses? We can take a blood test and we can go, this person is high on this, they have this thing. This is something we've been searching for a long time within psychiatry and psychology, whether it's brain imaging, some sort of blood marker. We were hoping that HRV was that thing, but it is not specific enough. All we can say is that no matter how many times we measure it, yes, there is a reduction. We take a sample of people with depression or with anxiety or with alcohol dependence, and these compared to people without these conditions, HRV is lower. So what we have learned though is that the one thing which seems to better explain differences between people is how much general anxiety that they're experiencing. People, regardless of the psychiatric condition that they have, people with higher general anxiety tend to have lower HRV, whereas some people who have lower anxiety tend to have higher HRV. That seems to be the one thing which seems to play a role. So it's not the fact that you have this condition itself, it's how much stress that you're currently experiencing or how much anxiety. That seems to be the one thing. But it doesn't seem to be specific. We don't know exactly what is causing that. It just seems to be that there is some sort of anxiety or stress anywhere, and that's contributing to HRV. But I mean, yeah, and I guess the other thing we learned is how hard it is to measure. Even us within the lab environment, we try and control things as much as possible. Sometimes people will walk in, they're holding a bottle of water, and I'm like, "How much have you drunk?" "Oh, I just took I drank half this bottle walking here." I'm like, "You're gonna have to come tomorrow because we're gonna get inaccurate measures." There are so many factors which can influence this within a laboratory environment, and also when you're sort of testing these things yourself. So those things have been quite fascinating, and it's a lot difficult to test. So even things like talking, yawning, like little things that you wouldn't think influence HRV, they influence HRV, and all it takes is a little bit of movement or a cough or a laugh, and then that could influence your recording. You have to be like, there are so many things. Like, this is very susceptible to artifacts. There was a paper written, I think, in the late 90s, which highlighted that all it takes is one beat that's not accounted for, and your measurement's inaccurate. Really, really sensitive to these sorts of errors.
And when you say artifacts, is that kind of heartbeats that are false, or how would you define that?
Yeah, that's a good way of putting it. So these are heartbeats which did not have their origin from activity at the sinoatrial node. That could either be because you're moving and the electrode jumps a bit, and that jump is due to the movement, not to the sinoatrial node. Or it could be other things which influence the electrical conduction of the heart, which lead to what we sort of normally know as like a skipped beat. For instance, you're not measuring sinoatrial activity. That's something else. We do have established algorithms which can detect these artifacts. So most of these apps will run these algorithms, and some do a better job than others, but they essentially go through and they identify what is a real beat versus what is a false beat, for instance, and they will actually identify it, and they will try and repair it and interpolate and put in where the beat should be based on established algorithms. These algorithms are public, they're commonly used, but quite often, at least within our research, the algorithms are quite good. We use them to identify potential missed beats, but we'll still visually look through the cycle and go, okay, that is true variation, whereas that is a false beat. And if it's a false beat, then we'll we'll fix it accordingly. A lot of these apps will do this in the background. Again, sometimes they describe very well what they're doing. So HRV for training uses some of the established algorithms for detecting and fixing artifacts. Others, we're not sure what they're doing.
Yeah, I also used an app called Elite HRV, and that also gave me like it shows if there are artifacts in the measurement, but it doesn't say, of course, what caused it. It just says that we found these artifacts and we corrected them for you.
Yeah, that is one of the limitations of using anything other than ECG, is that the source of the artifacts whether it's movement or whether it's a skip beat. It's unclear. They'll take their best guess.
Yeah. And another topic I wanted to ask you about, I mean, you alluded to it before, but are there any gender differences in HRV? And do you know anything about how HRV changes during the female menstrual cycle? Because my colleague,
Yes.
Gina, she really wanted to know.
Yeah. This is a really important question. So yeah, in terms of differences, somebody that's the same age, on average, women have slightly higher HRV. This does change across the menstrual cycle. So before ovulation, it's a little bit higher. After ovulation, it drops. These are noticeable changes in HRV. So there certainly are differences across the menstrual cycle. Again, these are averages. So on average, this is what we find. Some individuals might not find this, but on average, this is what the research has found, that there is increase before ovulation. After ovulation, it decreases.
Yeah, that's maybe an issue with some of these smartwatches, that they don't take that into consideration. I mean, the algorithm just tells you that you're, overworked, or that you have too much stress, but it can be part of the cycle response.
Yeah, certainly. I mean, it's hormonal levels change across the cycle, and these have various effects on our physiology. And these apps, it's another contextual thing that these apps need to account for. But again, one person might find that they do follow this particular trend where it's higher before ovulation and lower after ovulation. But then next month, they may not find this because there might be other contextual factors, increased stress, for instance. So differences in hormonal levels can contribute to these differences, but these may be overridden by other factors as well. This is just another factor to consider when it comes to how these changes are. So, all things equal, there are differences across the cycle, but these could be overridden, and these could cause differences.
Yeah, and as a follow-up to that, do you think women should change their training based on their HRV during the different phases of the cycle?
I don't think so, because these changes could be caused via different things. And again, you might follow this characteristic pattern. You may not follow this characteristic pattern. So using this, you have to take into account how you're feeling, subjective feelings, and other factors which could influence HRV. But I don't think that these potential impacts on HRV across the cycle should be used to heavily dictate training load across the cycle. The evidence right now isn't there for that.
Yeah, that's also kind of the conclusion we had so far on the podcast.
Okay.
Yeah, so that's great to hear that you
Good. I'm glad.
agree on that. But another topic related to that is kind of like, if your HRV is higher, should you kind of use that as a measure to dictate how hard you can train? I've seen studies coming out of Finland. I think that's so that if you kind of do your high intensity training on days where HRV was higher, you could get like more, perhaps more value out of it. Do you have any thoughts on that?
Maybe because it may assist with your body might be better set for recovery. But I haven't seen any direct data on that. It's one of those things that it makes sense on paper. It could also be a placebo effect as well. You might think, well, I'm ready to train a little bit harder so I can do this. But that I haven't read any direct research on, so I can't really answer that particular question with a ton of confidence.
Yeah, I mean, it comes down to the big picture, right? And seeing that your actual HRV goes up over time, and not overthinking if it's high or low on a particular day, right?
Yeah, thinking about the trends, looking at the overall trends, using this reliable morning measure. A lot of the apps that are currently used are calculating HRV over the course of a day. Again, that's looking at the autonomic nervous system and other factors, and other factors can influence these things. Whereas if you're measuring it first thing in the day, it's relatively controlled, and you're more likely to get a measure that you can compare within yourself from day to day, and you're able to look at the overall trends, and you can be confident that this is a measure which has been validated decades ago. So it's reliable, and these devices are fairly reliable as well. They're pretty good. They're pretty close to ECG.
Yeah, but as you alluded to in your research, even in a lab, it's difficult to measure the HRV with high reliability, right? So there's always going to be kind of other things to take into consideration, and the context, like you said, if it's also important, like what did you do the day before, or what's kind of like the bigger picture causing higher stress, or
It's certainly something that comes like we always ask participants when they come in, like how they are anxious in general and how they're anxious right now and today. So we can look at both their sort of general personality, what we would call trait anxiety, but we also look at what we call state anxiety. What is your anxiety right now? I think another sort of hunch that I have is that a lot of the differences that we see in HRV with folks with anxiety is because during the measurement in the lab, they're feeling anxious. Someone comes into the lab and we tell them, can you sit still and do nothing for 5 minutes? And they're sitting there thinking, am I doing the right thing? That in itself can cause anxiety, which reduces HRV. So in response to that, what we've done in the lab and what a lot other labs do is they get people to do a boring task, to watch like a aquarium scene on TV, to distract them a bit. Nothing that's too exciting because that's going to influence HRV. It's called the vanilla task. Vanilla because it's boring. So it's something like that's a very, very light, sort of cognitively doesn't stress you enough. And that distracts people because we just got the feeling that a lot of folks, if they're sitting or if they're lying down, they feel very stressed. They overthink things. Sometimes we can tell whether some people are doing box breathing or meditating because we can actually see the characteristic waves. So we have to tell them, can you breathe normally? Because people start doing that, and that can influence HRV as well. So doing these tasks where we get people to focus on a boring task can certainly help, and that is one potential benefit of measuring HRV during sleep, because you don't have these confounds. You can't influence your HRV via breathing, and that's a really important aspect to consider is respiration as well. We always tend to measure respiration during HRV collection as well as an additional measure. You can have these bands that go around your chest to sort of measure how fast you're breathing as well. That's a really important consideration. And some people have started, there are things called biofeedback therapy where you can actually increase HRV by doing breathing exercises. I think that's the topic for an entirely different episode. But
I was going to ask you about that actually, because I did some research on that, and I found that it certainly shows promise.
You certainly, yeah, you can reduce anxiety. So we did something similar. We did an experiment in musicians with performance anxiety, and seeing with the biofeedback, we got them to come into the lab and play a really hard piece. And some of these people had this sort of biofeedback training to increase HRV. And at least when it came to self-reported stress, there were improvements there. So these things, yeah, we can manipulate our autonomic nervous system via our respiration, because if we're breathing out slowly, then we're slowing down our heart rate. So this is one thing that can be done. Other than that musician study, which I think was done like 15 years ago, I haven't really looked at this again, but it is a really interesting avenue because we can manipulate our autonomic nervous system simply by changing the way that we breathe.
Yeah, that's very interesting. And for those people that like to see numbers, and I think one of those apps I use called Elite HRV, they have this biofeedback exercise in the app, so you can actually see live feedback on your HRV and your heart rate during the practice.
I think I was on their podcast like 10 years ago, I think, for
Oh, yeah?
Elite HRV. So now that you mentioned that, yeah, that very much rings a bell. So yeah, a lot of these apps can implement some sort of biofeedback thing aspect, and that certainly is one approach for increasing HRV as well.
Yeah, that's awesome. I mean, we have to wrap it up soon, but is there anything else you'd like to add before we finish?
I think if you're interested in this sort of stuff, have a careful look at the devices that you're using and the measures that they are using to create the metrics that they have. Look for ones which create established metrics, particularly something like RMSSD, because those things have been validated to be measures or accurate measures of heart rate variability. Context makes a difference as well. So consider the context when you're recording. Those are the most important things to consider there.
That's great advice. So thank you so much for coming on the podcast, Dan.
My pleasure.
Really appreciate it. I think the listeners will enjoy it as well. And if people want to get in touch with you, where can they find you?
I think the best way would be Blue Sky, DS Quintana on Blue Sky. That's where I'm sort of most active. Also on LinkedIn as well. So if you search LinkedIn, my name, University of Oslo, I should come up. Those would be the easiest ways. If you're interested in research methodology as well, you can also check out my podcast, Everything Hertz, everythinghertz.com. And I think we have 182 episodes. So it's been going for a while. So if that's of interest, research methods within psychology, then check that out.
Awesome. Thank you very much.
Thank you.